Okay, let's go through the contents of this video first. First, I will explain about the Arduino board, and then I will explain how we can produce the 16.7 million colors using RGB LEDs. Then I will explain the hardware schematics that will include your Arduino board, which is connected with the RGB LED. And then I will explain how we can add the hardware support package for Arduino to the MATLAB. So you can access the Arduino board with help of MATLAB. Now I will explain how you can design the graphical user interface with help of MATLAB's guide. And then in the last, I will explain the MATLAB code that will be used to generate different types of colors using that RGB LED. So let's go ahead. First, let us see what is the Arduino board. The Arduino board actually is an open source microcontroller board that is based on the microchip Atmega 328P microcontroller, which is developed by the Arduino.cc. Let us have a look on some specifications of this microcontroller. This microcontroller operates at 5 volt and it has an input voltage limit from 7 to 12 volt, which can reach maximum to the 6 to 20 volts. It has total 14 input output pins, out of which 6 provide PWM output. Later I will explain you what is this PWM output. And it has a total 6 analog input pins. For DC current limit for the input output pins is 40 milliampere. So this has to be noted because it will help us to find the appropriate resistance value to be connected to limit the currents if we are driving some LEDs or some load. And there is another pin, 3.3 volt pin here, which has a current capacity of the 50 milliampere. Its flash memory is 32 KB, its RAM is 2 KB, its ROM is 1 KB, and this microcontroller operates at 16 megahertz. And now let's have a look on its different components and pins. So this is your USB connector. With help of this, you can connect your board to the computer, a laptop, where you can program this microcontroller. And this is a power supply jack, so you can connect an external power supply to it. This is your hardware reset button, and this is your microcontroller, that is Atmega 328P, and it has the 6 analog pins from A0 to A5, and it has 2 serial pins, I mean 0 and 1, TX and RX, you can see. So they are used for serial out and serial in. And from pin number 2 to 13 you can use as digital input output pins. You can configure them, the same pin you can use as input and same pin you can use as output. And here you can see that few pins have this tilde symbol along with their numbers, such as 11, 10, 9, 6, 5 and 3. So these pins are actually have the support of the PWM, that means a pulse width modulation. These pins can give any voltage in the range 0 to 5 volt. So with help of PWM. So in the coming slide, I will explain how they produce the different voltage using PWM. Now let us see how we can produce the different colors with help of the RGB LEDs. So we have actually the 3 primary colors, as we know, the red, the green and the blue. So when we mix red and green, we create yellow, and if we mix red and blue, we create magenta, and with help of green and blue, we create cyan. And also with their mixing with the different proportions, we can generate any color. So let us see how. So suppose this is part of your Arduino board, where one LED is connected to the pin number 9, which also supports the PWM. That means this pin can generate the minimum 0 volt and maximum it can give the 5 volt. So that is the limit. So your LED one will receive 0 volt, it will be switch off. When it will receive the 5 volt, it will run at the full brightness. And actually this LED, you can say it is controlled by the 8-bit controller inside. It means because of this 8-bit controller, you can have the total 256 variations in the voltage in this range from minimum 0 to maximum 5 volt. So it means because of the 256 variations means that one step of variation will be the 5 upon 256, that is the 19.53125 millivolt. So if the minimum voltage is, let's say, 0, the next voltage will be the 19.53125 millivolt. With these increment or decrement or total 256 variations, your LED will produce the total 256 intensity variations in the light. And suppose you are producing the color, so you are using the RGB LED. It means you are using 3 such LEDs, one for red, one for green, and one for blue. And since one LED produces total 256 variations, then all the 3 combined together will generate the total 2 power 8 into 2 power 8 into 2 power 8, that is 2 power 24 variations, that is equivalent to 16777,216 variations. So it means these 3 LED combinations, I mean the RGB combinations, can create 16777,216 total number of colors. So that is in general can be approximated to the 16.7 million colors. So this is the same number which you generally hear from the display manufacturers, such as in case of your mobile phone screen or in the television screens. They claim that their screen can produce the 16.7 million colors. That is because of this fundamental which I have just explained, because of this 8-bit variations. And as I said that from the Arduino PWM pins, I mean the pin number 10, either it is 11, 10, 9, 6, 5 or 3, these pins can give you the intensity variations in the range 0 to 5 volt. And how it is achieved actually? So this is achieved with help of this 8-bit controller and by producing a square wave whose duty cycle is changed to produce these voltage variations. So that is known as the pulse width modulation, or PWM in the short. So this fundamental is similar to the DC chopper, if you are aware with the DC chopper, which produces the variable DC output from a fixed in DC input. So in case of DC chopper, if your input voltage is, let's say, Vi, which is the fixed DC, then output voltage V0 will be the duty cycle multiplied the input voltage. And here duty cycle can vary from 0 to 100%. So you can create any voltage in the range 0 to 5 volt with this expression. And this type of different or variable DC output you can create with help of this command, that is the analog write pin and the value in the original programming IDE of Arduino.cc. And the similar action you can achieve in the MATLAB also with help of this function, that is the write PWM voltage. This is a board variable and this is pin number and then value. Suppose here I am using the pin number 9, so you will write like this 9 and then 5. 5 means a 5 volt. You can give 0 volt or you can give any voltage in this range 0 to 5. Now let us see the hardware implementation. So this is your circuit diagram. This is your Arduino board and this is your RGB LED. Instead of using 3 different LED, I mean one for red, one for green and one for blue, I'm using a single LED which is known as the RGB LED. It better produces color as compared to the 3 different RGB LEDs. And here we have used 3 resistors for each channel, RGB channel, to limit the current, because as I said that Arduino can maximum provide 40 milliampere, so your current should not exceed. And also we should see that how much maximum current your LED can handle. So this LED can handle maximum 20 milliampere current per color channel. So obviously we have used the 220 ohms for each channel. So since your board can produce maximum 5 volt, so the maximum current will be the 5 volt upon 220 ohms. So obviously it is lesser than 20 milliampere. We can further reduce this ohm value to have current near the 20 milliampere. That will increase the brightness of this LED, but it is safe to use a little higher side of the resistance. So this is a very simple schematic. Anyone can easily connect this circuit on this breadboard. And now let us see the RGB LED. So we have the two different types of LED. One is the common anode and other is known as the common cathode. So in this circuit I have used the common cathode where there is a one common terminal which is made by connecting all N side of these LED. As we know that these LEDs are actually the diodes, as its name, light emitting diode. So by the diode construction, each LED has a PN part. I mean P type material, N type material. So all N side are connected to have a common terminal which will be the grounded. And if you want to suppose switch on this red LED, you have to apply 5 volt here. So you can control the LEDs like this. And similarly in this common anode, actually these terminals will be grounded. And if you apply the 5 volt, your LEDs will be on. So if you want to switch on a particular LED, you have to ground that particular side of the LED and just leave either open the other LEDs or apply the 5 volt. So if both sides are 5 volt, your LED will not switch on. So only one LED will be switched on which has the ground at the other side. Okay, so to produce different colors, what you will do actually, suppose in this case you want to produce only a red color. So obviously you will give 0 volt to green, 0 volt to blue. You will give only the 5 volt to this red LED and it will run at the full brightness. So you will get the red color. So you can represent this as 1 0 0. So 1 is actually you can see it is corresponding to the maximum 5 volt. So I am scaling, I mean 0 volt to 5 volt, I am scaling in the number 0 to 1. Okay, so if I am writing 1 here, it means I am giving the full voltage to the red LED. So to produce, so this is your red, and to produce green, obviously what you will do, this 0 1 0. So it will produce green color. That means a green LED is getting 5 volt, full 5 volt. And to produce blue, you will give this input 0 0 1. So that will create the blue color. And you can give the combination. Suppose you want to create the yellow color. You want to create the yellow color. So what will be the RGB value? Obviously you have to create you have to switch on red and green simultaneously, and blue should be switched off. So your red is on, green is on, and blue is switched off. So this will create yellow. And for RGB, let's say 0 1 1, what color it will be? Where green and blue are on, it means you will get a cyan color. And if RGB is let's say 1 0 1, what color you will get? I mean the red is on, blue is on, green is off. You will get the magenta color. Now you can have the different proportions of the intensity. For example, if I give the RGB equal to 1.40, what does it mean actually? So 1 means we are giving full 5 volt to this red LED. 0 means the blue LED is switched off, and 0.4 given to the green LED, it means we are giving the 40% of the 5 volt to this green LED. So it will be running at the green side, but at the darker green, because it is not running at the full brightness. So these two combinations will create an orange shade, orange type of shade. So you can actually create all 16.7 million colors with these variations. So you can mix these numbers in any proportion and you can get any color. Okay. So this principle I am going to use to produce the different types of colors. Now let us interface Arduino with the MATLAB. We will see that how we can access the Arduino in the MATLAB. So to access the Arduino in the MATLAB, first we need to install a hardware support package for Arduino. So how we can install it? So we can install it from the MATLAB itself, but we need to have our login on the mathworks.com. So if you see this MATLAB ribbon on the top, you can see that this at this corner, the login is written. So you just press it, it will ask your account. So just enter your credentials and you will get your name here, I mean whatever you have written. So it means you are logged into your MATLAB. Once you are logged into your MATLAB, just go to this add-on button. So you press it. So when you press this add-on button, you get this drop down menu. From there you can select this get hardware support package. So when you click this, you get this type of window. It will open to you, and here at the very first you can see you get this MATLAB support package for hardware. You have the Simulink support package also for the Arduino. So that will I will cover in some later videos how we can access the Arduino with help of the Simulink. But here I'm talking about this, that is the MATLAB support package for Arduino. You just click it, you get this type of interface. So some details are written here, and here you will get a download button. Since it is already installed in my computer, so it is showing the manage. But here if it is not installed, a download button will be shown here. And here you can see the important information that this is supported only the MATLAB versions R2017B and later. Before this, this support package is not supported. So be careful about it. And once it is added, now you are ready to control your RGB LED. Now you are ready to control your Arduino board. So now let us see the MATLAB implementation. Actually here I will create a graphical user interface to control your LED. So I will create this type of graphical user interface where I have created one button that when you press it, your board will be connected to your MATLAB. And these are the radio buttons where you can select your color to be produced using LED. So if you select this red, your LED will be showing the red color. If you select this green, your LED will be showing the green color, blue, white, magenta, cyan, yellow, etc. And if you select this, your LED will be switched off. And you can make any custom color as I have explained. So here you have to enter the custom values of RGB. So if you enter, let's say 0.40, and if you press this OK button, your LED will be showing this color, that is 1.4, which is slightly similar to your orange color. And that orange color will be produced here. So you can match this color with your LED color. And with this exit button, you can exit this GUI and you can switch off that Arduino board. So here I will show you that how you can design this graphical user interface in MATLAB using MATLAB Guide, GUIDE. But before going ahead, let us see different tags which I have used in my MATLAB Guide. Actually, I have changed the name of a few guide tags. so that I can easily locate them. I mean their corresponding callbacks I can locate in the corresponding MATLAB program. So it makes it actually easier for me to locate a corresponding MATLAB callback. If you don't do this, no problem, then you have to identify the correct callbacks. For example, this button tag is by default is push button 1, and this will be the push button 2, this will be the push button 3. So this is how the MATLAB gives the name to each buttons. Similarly, for radio button, MATLAB gives the radio button 1, radio button 2, radio button 3, like that. And for these text field, static text, the MATLAB gives the name like edit 1, edit 2, edit 3, edit 4, and so on. So just to make it easier to locate their corresponding callbacks in the MATLAB program, I have just changed the name in the program. So here I have given all these names, which you can see in my MATLAB program, which I will show you later. So there will be no confusion. Now I will take you to the MATLAB and I will show you that how you can design this graphical user interface. So let me jump to the MATLAB. So let me open the MATLAB. So this is my MATLAB command prompt, and here I will write GUID, guide. So when I execute this guide, this quick start menu opens and it asks me to create a new GUI. So I will create the blank GUI default, and this is OK. So when I press OK, this windows open, and this gray color, you can see that this is the size of the window which will be designed. But as you have seen in my GUI, it is slightly more in the length, so you can resize it to create the window size. Okay, and now I can show you that how you can put the different buttons and radio buttons, etc. So this is your buttons. You can just drag and drop. You just press, you drag and then drop. So this is your first button. You can resize it, and you can put another buttons in similar way. And if you want to avoid the resizing every time, so it is better to duplicate it. So your all button will be of the same size. So this is your second button, and again you can duplicate it. So this is your third button, and you can rename them. By default the push button is written here, and you can rename. Just right click and go to the property inspector. So when you go to the property inspector, this windows open, and just locate the string. So this is the string, and here push button is written. You can just remove it, and you can change its name. So for example, I gave the name board on in my program. So this is board on, and this is the tag you can see. So in the previous slide, I actually shown you that those changed tag name. So MATLAB gives this push button 1, that is the default tag. But if you want to change this, you can change it. For example, let me change it. So this will be the board on. So you can actually, this will help you to locate the corresponding callback function in the MATLAB program. So I have changed its name, and you can change its color also. If you go to this background color and press this, you can change its color. Suppose you want to make it some brown color or something else, for example blue, you can create like this. So this is a color of default color of this button. Similarly, you can change it. So go to the property inspector, and this button was the exit button in my program, as you have seen. So I write exit. So this is, you can change this button name. Similarly, this button was OK button. So you can again change the string from push button to, you can write OK, and you can also change its tag. So you can change OK here also. So that will help you to easily locate its corresponding callback. So this is the OK button, and those Colors I created with this static text. So just drag and drop and change its size and just duplicate. So this is my, let's say, red color, this is my green color, duplicate, this is my blue, and again duplicate, this is my let's say white, and so on. So you can change its attributes again by calling the property inspector. You can change its background color. So I'm choosing the red, and the static text in the black color is written here. So if you want to avoid it, you can change its foreground color. So you choose foreground color also red, so it will be invisible. Similarly, you can change this next one as let's say green. So this is your green color, and the foreground color is also, let's say, green. Okay, so this is green. So this is how you can create all those color field here, and from here you can create a button group. Okay, so you just create a button group like this, and from here you can put the radio button. So you just drag and drop the different radio buttons like this beneath all the these color fields, and you can change their name again with the property inspector. So suppose you want to write red here, just go to the property inspector and you just change the string. So when you change the string, you get the red name here. So here you can see that this is converted to the red. So this is red. Similarly, you can write green here. Similarly, you can write blue here, and so on. And here I gave one editable text so that you can drop from here to enter the different RGB color combinations. And again, you can change its name, etc. So once this is complete, you just save it with some name. Let's say save as, and let's say RGB GUI with some name in your directory. The MATLAB will automatically write program for you. So when it is saved, you can see that a MATLAB corresponding file is instantly generated. So here you have to modify this MATLAB file. Actually, this is just a skeleton. So you cannot do anything right now because for the corresponding callbacks, nothing is there. For example, if you press this button, nothing will happen. So if you want to see this as a standalone graphical user interface, you just press this green triangular button here, and you will see that this window is created. So whatever I have designed here, that GUI window is created. So but here nothing will happen when you select the red radio button or press this button, something else, because I have not written the control commands for each callbacks. So how to do that? Suppose you want to write for this board on, you just right click and go to the callbacks, view callbacks, and then callback. So when you press this, you directly jump to its callback function. So you can see that function board on. So you can see that board on, that was the tag which I have changed during the guide. So by this you can also recognize that this is related to that board on button. So board on callback, and here you will write your control commands so that when you press this button, so whatever you define here, that will be executed. So this is how you can create the GUI for the MATLAB. Now I'm going to the program where I have given all these control statements. So let me jump to the my presentation where I have written this program, so I can explain easily. So this is the MATLAB program which is generated automatically by the GUI which I had just shown to you. So these lines are generated automatically, so nothing to do with these lines. Actually in this program I have removed various lines which are not required, lots of comment lines, etc. So this is actually the compact version. And here you get this opening function. This is common to all GUI. So again, you don't have to change anything here. And this is your output function, again, which is common to all GUI. Again, no need to change anything here. And now our control statements start from here. So this is the board on. That means this is your first button. By pressing it, your Arduino board will be connected to the MATLAB. So these are my lines which I have written. So first we have to declare a board variable, which is the A, that is A Arduino, by which your board will be connected. And here I'm making a handle of this board variable. So handles.a equal to A. And then I'm creating one condition that will be later used for enabling those color radio buttons. So I'm creating handles of one variable on, and it is equal to 1. So it means once the board is connected, your on will become 1. And here I am checking the condition whether the board is created or not. So if not is empty, handles.a equal to 1, it means if board is created, then change the color of the button to the green. So what will happen if you press that board on button, its color will be changed to green. It means your board is connected. So that will be like an indication. So this is the end of your if, and just update your objects and handles. So this is just for your board on button. Now come back to your first radio button. So if you remember that GUI where you have the first radio button for red, choosing red. So if you select this radio button with help of mouse, if you click over it, your callback will be transferred to this function. So what will happen? Obviously the LED should run with a red color. So what type of RGB value should be created? 1 0 0. It means in physically it should be the 5 volt 0 volt 0 volt. So this is done with these commands. So if handles.on equal to 1, it means it is checking whether the board is connected to your MATLAB or not. So this becomes 1 only if your board is on. So obviously your board is on because you have already pressed that board on button. Now these lines will be executed. So here you can see that write PWM voltage. This is already I have explained. So this is a board variable A, and this is the pin number D6. And 5, I'm sending 5 means I'm sending the 5 volt to this pin number D6. So here you can easily see that your both the LEDs, I mean green and blue, are off. Only the red is glowing at the full brightness. And if the second radio button is clicked, this function is executed where we select the green. So here you can see that the red is off, I mean 0, blue is off, and then only green is on. So obviously the green color will be there. And if the third radio button is selected, which is for blue, so you can see that 005 means red is off, green is off, only blue is there. Similarly for fourth radio button, which is for white. So white color can be produced by switching on all the 3 LEDs. So white can be created by this RGB value. So 1 1 1 means in physically it is 5 volt 5 volt 5 volt. So if you give 5 volt to all LEDs, all the 3 LEDs will glow at the full brightness. So that will create the white color. And this is for magenta. So here only the red and blue are on, green is off. This is for cyan, where red is off, green and blue are on. So you can create the cyan color. And with the radio button 7, you can create the yellow. So I mean the red is on, green is on, but blue is off. And here radio button is for the switch off lights. So that means all red, green, blue, I mean 0 0 is given. So your all the 3 LEDs will be switched off. And these lines are for your exit button. So since we have changed the tag, so instead of push button, the exit is written here. and we are clearing this board variable, a board object. So board object is clear. That means your Arduino board is disconnected from your MATLAB, and close request means your GUI is also closed. And here we are creating the custom colors. I mean, with giving any value of RGB, we can create any color as I already shown. So let's say if you give 1 to R, 0.4 to G, and 0 to B, you can create orange shade of light. So you can create any color with help of giving these RGB values. So this is the code for doing that job. So we are accessing here that editable text field. So since I have changed the name of that text field by the enter RGB, so when you enter anything in that editable text, this function is executed. So here you can see once we enter anything, we are getting that value by the get function. So we are getting that anything which we have entered that text field in the form of string, and we are converting that string into the number, and we are extracting the RGB values. So handles.r equal to RGB1. I mean, we are taking the first value, second value for green, third value for blue, and updating the handles. So all the RGB values are now entered into the handles.r, handles.g, and handles.b. And these are the default lines. You don't need to change anything here. And here, this is your OK button. So when you press this OK button, your LED glows with the defined RGB value. So obviously you have to send these RGB values to the Arduino board. So obviously when this button, OK button, is pressed, you are writing this PWM voltage to your board at the pin number D6. So whatever value R is given, I mean whatever value for red is given, that is given to the pin number D6, and for green pin number D5, and for blue pin number D3. So your RGB LED will show that corresponding color. Okay. And also besides that editable text, if you remember that GUI, I have created one non-editable text field. So that is that has the tag text 15 in my program. So I am accessing this tag field, and with that entered RGB value, the LED is glowing with the same color. At the same time, this text field also changes its color with these defined RGB values. So you can compare whatever color is shown here. Same you can see that almost same is shown by your LED also. So this is your program. You can execute it. So I will show you how you can generate the different colors with help of that Arduino board and the RGB by executing this program. But before going to the execution, let me show you the output of this program, which are captured by the camera with a special setting, because the camera has a problem because at every color it changes its focus or its ISO label or its exposure, etc. automatically if your camera is in auto mode. So there may be not exact color which I can show you here, but here with a controlled I mean the manual settings of the camera, now I could able to capture the colors, those colors effectively. So let me show you those colors. This is the photograph of my actual implementation. So you can see this is the Arduino board, and this is your RGB LED. So it has the 4 terminals. So this is your common cathode terminal, so which is connected to the ground. So this is going to the ground here. So you can see on the board. So this is connected to the ground, and this is your red, and this one is green, and this one is for blue. And here you can see all the 3 resistances of 220 ohm to limit the current. Okay, so they are connected. The red is connected to the pin number 6, which is PWM pin, and green is connected to the pin number 5, and blue is connected to the pin number 3. So this is simple setup, anybody can do it. And now let me show you the output. So this is a red color which is produced by this RGB LED, and the corresponding value is 100, you can see. So this is the color which is visible on your screen, and here you can see that this is the color which is produced by the LED. And this is the green color. This is what you see on your screen, and this is what you see by the LED. And this is the blue color. Its RGB value is 001. This is what you see on your screen, and this is what the LED is producing. And this is the white color. I mean, 11 means all RGB are glowing at the full intensity. So this is what I'm getting as the white. And this is the magenta. You can see that 101 means red is on, blue is on, you are getting this. So and this is what you are getting with your LED. And this is the cyan 011, and this is the yellow 110 means red and green are on, blue is off. And this is a custom color. So here red is fully on, that means 1. The green is at the half intensity and the blue is at the quarter intensity. So you get this type of color. So you can match whatever light you are getting from your LED. It is quite similar. And you can see another custom color, 0.5, 0.50. So a dark greenish, a shade of green. You can see it is quite matching. And this is the brown. You can match with the LED. And this is the orange, which I was talking quite frequently, that 1.40. So blue is off, red is at full intensity, and green is at 40% intensity. So you can match the color. It's quite similar. Okay, so this is how I can get different types of colors. So now let me jump to the MATLAB, and I will show you by running that hardware. Okay, so let me jump to the MATLAB. Okay, this is the circuit board. You can see the Arduino is connected with the breadboard, and this is the RGB color LED, which is connected to the 3 resistances of 220 ohm each to limit the current. And now I will show you that how you can create the different colors with help of this Arduino board and this RGB LED. So for that I will run that program. So this is my MATLAB program, and it is already written. And let me run by pressing this run button. So when I press this run button, you get this GUI, which is made using MATLAB's guide, as I shown in the previous slides. Now I will connect the board. So when I connect the board, I will press this board on button. So as I said, once the board is on, the color of this button will change to green. So let's see. Okay, so it is turned green. It means your board is connected. Now it is ready to show the different colors. So now I'm pressing the red button. So here you can see that your LED will glow as red. Okay, so you can see that when I press this red, your LED is glowing as red. Now this is green, this is blue, and this is white. This is magenta, this is cyan, this is yellow, and this is light turn off. Okay, so LED is off. And here you can create any custom color by entering the RGB values, as I said. So now I am entering the RGB values. So let's say 1, 0.5, 0.25. So let me see what color I can produce. Just press OK. So this type of color is produced, and you can just see the LED. Actually, in the video camera, I don't have the manual settings, so I cannot reduce the exposure or ISO labels. So also the light is on in this space, so that light is eating that color. Okay, so but I have shown this color in the pictures which I have taken in the darkness with the control setting. Okay, so your LED is glowing with this color, and now you can have another color. Let's say 0.5, 0.5, and then 0. So some green shade should be there. Okay, so now you can see that this green color on the screen and the similar color with this LED. So again, because of the light in this space, I'm not able to show you, but the same color I have already shown you in my presentation with a controlled environment. So this is how you can generate the different types of colors with this arrangement. Actually, you can generate 16.7 million colors. So this is the scheme which is used even your color television or in your computer monitors to generate these different types of colors. Okay, so that's it for this video. I hope you have enjoyed this a lot and learned a lot of new things. Obviously, I hope that it has motivated you to try this at your home. So I really thank you all for watching this video. Goodbye.